Okay, let's get started with 6-7 permutations and combinations, which will be very helpful when we do probability problems. But for now, the two objectives here, we're going to count permutations and then we're going to count combinations. Two counting objectives here today. So, new vocab, permutation, n factorial, and combination. Three new things in the vocab department. So, let's get started with our skills check. I'll do 1 and 4, you do the rest. Here we go. Number 1, what's 10 times 9 times 8 times 7 times 6? That's going to be 9720. Let's get the calculator. That's a lot of work. Actually, you know what? I'm going to come back here. I'm going to let you do 1 and 2. I'm going to show you 3 because that's the technique that we want to learn here. This is 7, 6, 5, 4, 3, 2, 1 in the numerator. And in the denominator, we've got 4, 3, 2, 1. The key here, and this is something we're going to do a lot this chapter, is what cancels. The 4, 3, 2, 1 cancel. 7 times 6 is 42, times 5 is 210. We can do that. All right, let A dot B equal 2A, A plus B. So there's a formula here. So for 4, the formula is 2A, A plus B. What's our A? The A is 3. What's our B? The B is 4. Order of operations, we need to add first 2 times 3 times 7. 2 times 3 is 6. 6 times 7 is 42. All right, follow those steps for 5, 6, and 7. Go back to number 1 and 2. Pause the video. Press play when you're ready to go. All right, so what is a permutation? A permutation is an arrangement of items in a particular order. So the key on this is when we do problems where order matters, it's a permutation problem. All right, you can use the multiplication counting principle or factorial notation when you plan to choose all the items of a particular set. What that means is 7 people go swimming. We're going to put them in order from 1 to 7. We get to say 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial is. So factorial, if we do 4 factorial, and the exclamation mark is the symbol for factorial, what that means is multiply the numbers starting at 4, take yourself all the way down to 1. 4 times 3 is 12, times 2 is 24. All right? 10 factorial would be 10 times 9 times 8, all the way down to 1. All right? So, in how many different orders can you 10 dogs line up to be groomed? How many dogs line up first? Well, there's 10 dogs for the first spot. How many dogs are left over? There's 9 dogs for the second spot. How many dogs are left over? 8 dogs for the third spot, and so on, all the way down to 1. This is 10 factorial. All right, so we can multiply them, or we can grab our handy-dandy TI-84s and plug this in. So we're going to type 10. Then we're going to hit the math button, and factorial is over in the probability section. So we go over to PRB, factorial is a 4, 10 factorial, we hit enter, and boom, 3,628,800 different ways to line up those 10 dogs. So take your calculators and see if you can figure out how many different ways we can arrange 6 trophies on a shelf. Okay, so now, what if we want to line things up, the order matters, but we don't want to have the order of everything? Like, say we're running a race, right? And we wanted to have 10 people run the race, but we're only going to give awards to the top 4 people, right? So people 5 through 10, it really doesn't matter where you end up, you're not a winner, right? We only care about first, second, third, and fourth place. What we do then is we use our permutation formula, NPR. That means n factorial in the numerator, and then subtract the two numbers, n minus r factorial in the denominator. So here's an example. 10 over 10 minus 4 would be 10 over 6. And so on this one, if we were to write that out, it would be 10 times 9 times 8 times 7 times 6 times all the way down to 1, right? Over 6 times 5 times 4 all the way down to 1. Those 6's would cancel each other out. So really this problem is going to be 10, 9, 8, 7, which is what this is saying. Start at 10 and multiply 4 numbers, 10 times 9 times 8 times 7. And we can do this in our calculator as well. You'll see here that 10p4 is 5040. If we type 10, go back to math, go back to probability, and go to NPR, number 2. And then we type the second number 4, 5040. It'll do it for us as well. Okay, so you need to know how to do this by hand. You will be asked to do that, but have the calculator to check yourself as well. So 7 boats enter a race. First, second, and third places will be given to the 3 fastest yachts. How many arrangements of first, second, and third places are possible? So how many boats are racing? 7. Does the order matter? Yes, it does. So permutation. And how many places are we awarding winners to? 3, so 7p3. That's going to be 7 times 6 times 5 times 4 times 3 times 2 times 1 over, sorry, this is 7 factorial over 7 minus 3 factorial. Skipped a step. That's 4 factorial. So over 4 times 3 times 2 times 1. 7 times 6 times 5 is 210. That was one of the warm-up problems. Okay? And you can check that on your calculator using the NPR function as well. So go ahead and figure out how many arrangements of first, second, third places are possible if we had 10 yachts racing. Okay, so now we're going to move into combinations. A combination is a problem where order does not matter. Okay, for instance, the first 3 people to show up are going to win $10. It doesn't matter if you're first or second or third. You just need to be one of the top 3. So in that case, first, second, and third, or second, first, and third, or third and second and first, those orders don't matter. So there's a lot of repeats that we need to get rid of. And so you're going to see here the NCR formula is the exact same thing as the permutation formula. N factorial over n minus r factorial. But there's also this r factorial in here, which means there's some combinations that we have to cancel because we've already done them in a different order. All right, so 5c3, 5 on top, 5 minus 3, 2 on the bottom, but also we have now 3 factorial in the denominator. And so if we were to write this out, you would get 5 times 4 times 3 times 2 times 1 in the numerator. In the denominator, 3 factorial is 3, 2, 1. 2 factorial is 2 times 1. Those would cancel, but also the 3 would cancel. So 5 times 4 is 20, but over 2, and we get 10. So let's try an example here. Let's evaluate 12c3. Set up the formula. 12 factorial over 3 factorial times 12 minus 3 factorial, which is 12 factorial over 3 factorial 9 factorial. And so we've got 12 times 10 times 10. Apparently I can't count by ones. Times 11 times 10 over 3 times 2 times 1. And I'm not even going to write the rest because once we hit 9, we're going to start canceling things out. So they're all going to cancel out as we go there. So I can also do this. 3 times 2 is 6. 12 divided by 6 is 2, just to make my multiplication easier. 2 times 11 is 22. Times 10 is 220. Okay, go ahead and you can check that via your calculators with, in this case, 12. Go to math, probability, and CR, number 3 this time. And we're picking 3, and there's our 220. All right, so you're up. Try these A, B, and C, see if you can get the correct numbers, and then we're moving on. All right, and so this is the book, shows you how to use your graphing calculator just like we've already done. A reading list for a course in world literature has 20 books in it, and how many ways can you choose to read 4 books? So here's the question. Does the order in which you read the books matter? No, we just need to read 4 of the books. So this is a combination problem. And that's usually the hardest part of these problems, is figuring out, is it a C combination or a P permutation problem. So this is 20C4. So this problem says we're allowed to use the calculator straight off. Let's plug it in. 20C4. And there are 4,845 different combinations of books you could read. A lot of options. All right, so you're up. Of the 20 books, in how many ways can you choose to read 7 books or 12 books? Should be able to do it quickly on your calculator. And lastly, here we go. 10 candidates are running for 3 seats in the student government. You may vote for as many as 3. in how many different ways can you vote for 3 or fewer candidates? So this gets a little trickier. This is several problems in one, because what if you voted for no candidates? Let's figure that out first. So how many people are running? 10. Does the order you vote for them matter? No, they just want to get elected. How many are you voting for? 0. Or what if you wanted to vote for 1 candidate? That'd be 10C1. 2 candidates would be 10C2. 3 candidates would be 10C3. Since any of these things could happen, we need to add up all the different ways these things could happen. So let's go ahead and plug this in. 10C0 is going to be 1. So by definition, there's only one way to vote for no candidate. So anytime you have a 0 here, the answer is going to be 1. How about 10C1? That's going to be 10. There's 10 different ways to pick one person. So anytime you see a 1, it's going to be the same thing as the back end here. And then things will change. 10C2, 45, 10C3 is 120, so 1 plus 10 plus 45 plus 120, 176 different ways you could vote for these candidates. Alright, so you're up here. Keep going with this. Extend it. How many different ways could you vote for 5 or fewer people? So you can take what we did in the last slide and extend it for 4 or 5 as well. Alright, any questions? We'll go over this in class. Good luck.